Hello everyone, welcome back to the channel Mining Engineering. Today's topic Geographic Information System, lecture number 4. Concept of spatial data or representation of real world in GIS. Variations in the real world is infinitely complex. Closer you look, the more detail you will observe. Hence, it must be generalized, approximated, or abstracted in order to be represented within a finite database. Spatial data describe the location and characteristics of spatial features, phenomena which may be discrete or continuous. Discrete features are individually distinguishable features. The entities have a clear boundary, whereas continuous features varies throughout some continuous field. This is the example of discrete features where you can visualize the airport, the lake. Everything is discrete, separated from one another. Here, the continuous features where it varies throughout some continuous field. Any measurable or describable spatial phenomena can be observed in three modes. First one, spatial mode, thematic mode, and temporal mode. The spatial mode variations from place to place. In thematic mode, variations from one characteristic to another. In temporal mode, variations from time to time. Hence, the components of spatial data are location, represents the spatial mode of information, attribute data, capture the thematic mode by defining different characteristics of objects, phenomena can be shown in form of a table. Time captures temporal mode and shows the variation of phenomena over the time. This is one attribute table where there is a name, identification, the population at 90s, then area of that state, then the population at 92. This is the map and this is the attribute table of that map. Each object corresponds to a row of the table. Each characteristic or theme corresponds to a column of the table. Here temporal changes as a new table here. Time changes, the population 90, then population 92, then population 94, and we have created three different attribute table. And here in this type of representation, temporal changes as a new column. In this attribute table, the population 90 and population 92 have represented in adding one new column. Here, one new attribute table have been created. Scale or level of measurement. Data can be qualitative or quantitative, which can be further classified into four types based on the scale of measurement. Qualitative, nominal, where names are used for describing the data. In quantitative, ordinal, interval, and ratio. Nominal establishes identity based on names or unique number. John, Ellison, Mary, Andrew. Names are used to describe the data. In ordinal, establish order first, second, third, fourth, like this. In interval, the difference between numbers is meaningful, but the numbering scale doesn't start at 0. Division is not possible. Here the interval is used, the time interval between 11:05 from 11:10, then this one like this. The ratio measurement has an absolute 0 and the difference between numbers is significant. There are different types of representation mode. In sources of spatial data, primary data, it involves Direct measurement of objects and phenomena. Some commonly used primary data are remote sensing data, surveying, sampling, and GPS. Sampling practices normally followed. There are various types of sampling practices like simple random. Here, random data are chosen, then stratified random, then systematic, systematic unaligned, and the cluster. Secondary data refers to data obtained from maps, hard copy documents, etc. Different scanners and digitizers are used to convert these hard copy maps to digital format. Thank you. We'll see lecture 5 in the next video.